Hello folks. I recently had the opportunity to purchase a used Goal Zero portable solar system. While it is an older system, I thought I would show it to you as it helps demonstrate the sizing of a solar system. The system came in a nice Hardig 2750 wheeled case, that's the big green box. The battery is a 33 amp hour with a PWM charge controller, and it came with two Escape 30 foldable solar panels, those are on the upper left. I added 4 more Goal Zero 15 watt solar panels, which I have clamped together in pairs. My power distribution box that you saw in a previous video, that's the little yellow box, an old inverter, and 4 Light-O-Life lamps that we will get to later. So let's talk about sizing the system. First, the battery is 30 amp hours, but batteries don't like to be drawn down past 50%. So for all practical purposes, that means we have a 15 amp hour battery. Now let's look at the solar panels. When you add everything up, I have 120 watts worth of panels. Now volts times amps equals watts. So a 12 volt 120 watt system will generate 10 amps per hour. But our panels are really only 60% efficient on average, so that drops my 10 amp output down to 6 amps per hour. Across the 5 hours of peak sunshine during the day, that generates 30 amp hours, which equals the size of my battery. But wait, didn't I say my battery was truly 50 amp hours? That I did. The 30 amp hours allows me to charge the battery as well as supplying power to external devices at the same time via the power distribution box or inverter. Now let's take a look at the Light-O-Life lamps. That's the little white lamp next to the yellow box. These are the 3 watt 270 lumen version. They have a barrel connector for connecting to Goal Zero systems and a car adapter for other configurations. You can also chain up to 8 of them together. Goal Zero has a new model out that draws 4 watts and provides, I think, 400 lumens. At 12 volts and 3 watts, this lamp is drawing a quarter amp. I have 4 of them, and if they are all on at the same time, that equals 1 amp. So off my 30/15 amp hour battery, I could power all of them simultaneously for 15 hours straight. Or using them for 3 hours a night would provide me with 5 days of evening light between charges, providing I was not using the system for anything else. This is a quick demonstration of the Light-O-Life lamps. This is my garage, currently lit by 2 fluorescent shop lights suspended from the ceiling. And this is what the garage looks like lit by the 4 Light-O-Life lanterns. Definitely dimmer, but definitely doable if you're in a grid down situation. So hopefully this video has shown you the following. First, your panels need to not only charge your battery, but provide additional power for simultaneous charging and use in a single day. Second, your battery bank needs to provide multiple days of use for specified devices to account for days where you may not have sun. Now, my final thoughts on this little system. My power distribution box has only a 15 amp breaker, which limits me to a 180 watt inverter. I would probably want to upgrade my old modified sine wave inverter to a pure sine wave. Also, since the battery is lead acid and it is used, I'm unsure how many cycles it has. I may want to upgrade or replace the battery. At that time, I may look at replacing the PWM controller with an MPPT one, which is more efficient. But those are future projects, and this is a small, portable system for providing light and powering small electronics. If you found this video interesting, I encourage you to check out a couple of my other solar power videos. And if you have any suggestions or questions, please leave them in the comments section. As always, thank you for watching, and please subscribe.